Joining several other notable world air powers, Japan has developed an indigenous sixth-generation fighter, the Mitsubishi F-X. Creating a sixth-generation fighter jet is challenging, even though it's considered the most technologically advanced military weapon. Japan's F-X fighter jet is a great example of such advanced technology. However, in a world where advanced stealth technology reigns supreme, the F-X promises to be a game-changer, pushing the boundaries of what's possible beyond the range of traditional radar systems. The anticipation for the maiden flight of the Mitsubishi F-X Godzilla is intense. Hence, how extraordinary is Japan's sixth-generation F-X fighter compared to other stealth fighters? Join us as we uncover Japan's just-revealed world's most advanced fighter jet. The Japan Air Self-Defense Force, JASDF, has operated the Mitsubishi F-2 lightweight multi-role fighter since the year 2000. The local industry produced 98 examples from the period spanning 1995 to 2011, with the design being a modified form of the excellent General Dynamics, now Lockheed, F-16 Fighting Falcon. Headed by the Japanese Ministry of Defense Technical Research and Development Institute, TRDI. The ATDX is a concept demonstrator-only design at this time and is not intended as a direct copy for a more formal serial production, finalized fifth-generation fighter. However, data collected during its testing and development will certainly be used in a future sixth-gen fighter attempt, the F-X. Like other fifth-generation initiatives worldwide, the ATDX program is costly for the island nation and always at the mercy of local politics. It has since evolved into an unveiled technology demonstrator and is scheduled for its first flight sometime in 2014 to 2015. The ATDX initiative was born from the Japanese's rebuffed attempt to procure the advanced F-22 Raptor from the U.S. government. However, the country is committed to purchasing 42 planned F-35A Lightning II models and may add more to the order in time. This has not derailed the ATDX program. The preliminary Shinshin concept envisions a faceted airframe in the mold begun by the American Lockheed F-22 Raptor Air Dominance Fighter. The design positions a powerful active electronically scanned array, AESA, scanning radar system under a nose cone assembly ahead of the cockpit in the usual way. The fuselage is well blended into the wings, while sharp angles are specially used throughout. Assuming a twin-engine design, the ATDX will sport twin rectangular intakes on either side of the cockpit. Wings will include main appendages and tailplanes as normal, with outward canted vertical tail fins at the rear. The engines exhaust through specially designed, low-profile, low-signature exhaust ports. Thrust vectoring is envisioned under and between each rudder. Unlike fourth-generation fighters relying on fly-by-wire control, the ATDX is slated for the newer, speedier fly-by-optics control system. Also intended for the ATDX demonstrator is an onboard self-repair facility that will detect and, to the best of its ability, diagnose and repair failed control systems. The undercarriage will be wholly retractable. Keeping with fifth-gen fighters' low-signature, low-profile nature, the Shinshin will be developed with an internal weapons bay, radar-absorbing coatings for its skin, and advanced technologies. In addition to the airframe, engines remain the other half of the fifth-generation fighter challenge, and this challenge has been handed to Ishikawajima Harima Heavy Industries, IHI, for possible development and production of a new power plant. IHI XF51 turbofans with up to 20,000 pounds thrust. It is assumed that, like the groundbreaking F-22, the ATDX will feature Super Cruise support, allowing for reaching supersonic flight without using a thirsty and missile-guiding afterburner. A mock-up of the ATDX was unveiled in 2005, while a compact remote-controlled demonstrator, mimicking the expected Shinshin design, was tested in 2006. The project was authorized with proper funding in 2007. Should the ATDX program yield an indigenous Japanese 5th-gen development, the upcoming production series aircraft will be designated Mitsubishi F-3, following the Mitsubishi F-2, F-16, and the original Cold War-era Mitsubishi F-1. In addition, the ATDX has a running length of 46.5 feet, a wingspan of 30 feet, and an overall height of 14.8 feet. Its maximum takeoff weight is estimated at 28,660 pounds. Projected straight-line speeds could reach Mach 2. Additionally, Mitsubishi Heavy Industries was assigned to develop a fighter jet that they continue to support even after 2 decades. Today, Japan and its JASDF service face multiple threats from North Korea, China, and Russia, prompting them to seek an advanced, all-modern replacement for their aging fleet under the F-X Next-Generation Fighter Initiative. Initially, the JASDF planned to acquire the advanced Lockheed F-22 Raptor 5th-generation air superiority fighter. Unfortunately, its purchase was banned from export in 1997 by the American government due to sensitive technologies. After this setback, the nation had to decide whether to pursue another foreign solution or settle on a local development. They ultimately chose the latter, although they may still collaborate internationally. Furthermore, the F-X program owes its existence to the I-3 fighter project and the X-2 Shinshin technology demonstrator program. The X-2 became a flyable, one-off prototype exhibiting some of the qualities of the soon-to-be F-X, including stealth. It flew from 2016 to 2018 in the data collecting role. The initial F-X prototype is tentatively scheduled to complete its construction phase in 2024, with a first flight to follow sometime in 2028. Full-rate serial production will ramp up in 2031, and the JASDF is expected to induct the fighter into service during 2035. The current F-X form relies on embedded afterburning turbofan engines for the required performance over range and general survivability. This will promote a relatively large airframe, which is also expected to house fuel stores for extended overwater operations and a radar fitted alongside internally held weapons. In addition, the electric actuators will succeed in the ages-old hydraulic approach, and stealth qualities will figure heavily into the design to promote a reduced radar cross-section and deflection. This will be accomplished through special materials and onboard systems. Composites will make up some of the fighter's construction, reducing weight and enhancing performance range. The engine of choice is the IHI XF91 afterburning turbofan, developing an estimated 22,000 pounds of dry thrust and up to 30,000 pounds of thrust with reheat. The turbofan is notably narrow in its design to maximize the airframe's internal volume, allowing it to house more weaponry, fuel, and other pertinent systems. The F-X also comes with heat shields and an integrated bonded structure that will likely be made of composite materials. This will help reduce the aircraft's overall weight, giving the F-X a much extended operational range and giving the Japanese Air Force the much-needed flexibility with the air bases from which the F-X will operate. Regarding propulsion, one of the main companies involved in the project, IHI Corporation, has been testing a new jet engine, the XF91 low bypass turbofan engine, since 2018. This engine includes interesting exotic materials to help keep its weight down while increasing its heat tolerance to 3,702 degrees Fahrenheit, 1,800 degrees Celsius. The exhaust ports will be capped by thrust vectoring flaps, giving the F-X exceptional agility while also optimizing its stealth qualities. 2 such engines will be housed in the design, providing the fighter with excellent performance at the expense of greater maintenance and repair commitments and increased fuel burn. With afterburners, this engine can pump out around 16.5 tons of thrust. This is impressive, but slightly lower than the F119 engines currently installed on U.S. F-22 Raptors. The XF9 is slimmer and can generate more power at around 241 horsepower, 180 kilowatt apiece. Japanese engineers have also been toying with thrust vectoring nozzles for the XF91 engine, which, if successful, could provide the FX with some impressive mid-flight maneuverability. This feature is currently an integral part of the F-22 and Russian Su-30 fighters. Allegedly, the Chinese J-10 and J-20 fighters also have this capability. Though mostly known for its automobile manufacturing, Subaru will develop the landing systems for the F-X. The company has an in-house aerospace division that specializes in building wings and landing gear for commercial aircraft such as the Boeing 777. In addition, the F-X can control up to 3 drone-like loyal wingmen crafts which will serve as either sensor-carrying scout crafts or extra weapons platforms. This feature will significantly improve the F-X's offensive capability while minimizing the manned jet's exposure to enemy attacks. To ensure the craft's stealthiness, the airframe's design and materials will require technical support from Lockheed Martin and Mitsubishi to develop the F-X's airframe and system integration. As currently drawn up, the F-X utilizes a conventional design layout with an appearance akin to the American Lockheed F-22 Raptor featured by the USAF. The single-seat cockpit is covered by a specially coated canopy and positioned just after the pointed nose cone. The nose will house an advanced actively electronically scanned array AESA radar common to other modern fighters. Also, the main plane wing members are blended elegantly at the wing roots, while each features clipped tips, swept-back leading edges, and tapering trailing edges. The tail unit will not feature horizontal planes as normally seen. Instead, a pair of outward canted fins will double as vertical or horizontal tail surfaces for the required control. The engine pairing within the fuselage is given a slight gap between and exhausts through ports at the tail. A conventional tricycle undercarriage will allow for ground running. Beyond an assumed internal automatic cannon, the aircraft is slated to support all current and near-future air-to-air and air-to-surface launched dropped weapons, including missiles, precision-guided ordnance, and special mission pods. The in-development XASM-3 and anti-ship missile will be exclusive to the F-X fighter design and into maritime patrol sorties. A microwave-based weapon is also planned, giving the aircraft an instant solution to inbound missile threats. The current design sees the primary weapons load carried in one or multiple internal weapons bays to maintain a low radar cross-section. The fighter will likely also be given provision for external pylons for additional missiles and bombs, as in the F-22. The F-X is expected to carry a greater missile than the Lockheed F-35 strike fighter, which the JASDF currently operates in number. Like other modern planes, the F-X fighter platform will feature a wide field of view, WFOV, helmet-mounted display, and HMD. This HMD will provide the pilot with mission-critical data and system information, regardless of the aircraft's direction. The headset is expected to have advanced capabilities such as zoom, full-color imagery, and three-dimensional sound. If all goes according to plan, the F-X system will serve as the JASDF's air superiority solution for decades and will likely remain operational well into the 2050s. Beyond that, the product will reignite a limited aeronautics industry sponsored by the country that may very well expand capabilities to support international customers of the F-X one day. The F-X is an ambitious project with many pitfalls, and supporters look to avoid the controversy centering on the earlier, expensive F-2 and its reliance on American involvement. Dimensions and performance figures presented on this page are estimates based on the author's part and will be updated as new information allows. In addition, the radar sends electromagnetic pings to bounce off an object, and the more sharp edges, contours, jagged edges, or angles, such as vertical structures, the greater the return signal, meaning a radar system will be able to receive an accurate rendering of the shape, size, and even speed of an object or platform. Blended wing-body horizontal formations, with few or no protruding visible structures, such as tail fins of weapons pylons, do not generate a distinct or identifiable return rendering due to the absence of shaped structures for electromagnetic pings to bounce off. Therefore, a huge stealth platform such as a B-2 or B-21 is built to appear as though it is as small and indistinguishable as a bird to enemy radar. Very little information is available about the Mitsubishi F-X's stealth properties, weapons, computing, or sensing. So many remaining questions still need to be answered. However, it will likely be a twin-engine fighter with advanced technologies, including remote drone control capabilities, a VR-style helmet-mounted display, and a radar that can double as a microwave weapon to fry enemy missiles. The fighter, led by Mitsubishi Electric, is expected to incorporate advanced mission systems and electronic warfare capabilities, including self-defense jamming functions. The fighter may also be equipped with integrated fire control for fighters IFCF, which allows Japanese and possibly US fighters to pool their sensor and missile targeting capabilities, enhancing missile accuracy beyond visual range. Japan is a highly advanced technological nation, and the Japanese self-defense forces are collaborating with Italy and the UK on an emerging sixth-generation aircraft called the Global Air Combat Program, GACP. The project aims to design a highly capable next-generation fighter jet, which will have its first flight scheduled for 2035. The fighter will also connect with uncrewed aerial systems and be equipped with advanced sensors, cutting-edge weapons, and innovative data systems. From 2035 onwards, the new GCAP platform will replace the UK Eurofighter Typhoon and Japanese F-2 fighter fleets. By combining forces with Italy and Japan on the next phase of the program, the UK will utilize their expertise, share costs, and ensure the RAF remains interoperable with the closest partners. As a priority, the three GCAP partners are working on establishing a core platform concept and structures required to launch a development phase in 2025. Before then, details on cost sharing will be solidified based on national budget assessments. The United Kingdom plans to evaluate the requirements for unmanned aerial vehicles, UAV, and weapons, which may include the ideas of loyal wingmen or adjunct aircraft concepts, in addition to developing the GSCAP fighter jet. The GSCAP initiative is one of the two sixth-generation fighter designs in Europe. The Franco-German-Spanish project called the Future Combat Aircraft System, SCAF, is also competing. However, this program is facing issues due to political disagreements between Berlin and Paris over a work-share split, and it seems to be behind recently announced GCAP timelines for producing a fighter design. The U.S. Air Force and Navy are developing concepts for a next-generation fighter, but service leadership has not revealed many details about these efforts. Moreover, the new partnership, particularly the connection between the UK and Japan, indicates that funding a next-generation fighter will be much more reliable in the long run. The UK Ministry of Defence, MOD, does not have enough funds to support a fully fledged fighter program or even match the funding it invested in Typhoon as part of a four-nation consortium. On the other hand, Japan has a massive economy and an unequivocal requirement for fighters due to its proximity to China. Considering the status of UK, German, and French relations, the GSAP agreement is one of the only practical ways to achieve more feasible levels of funding. The United Kingdom seeks to boost its exports by welcoming more countries with similar goals to join the Global Coalition for Animal, Agriculture, and Public Health, GCAP. However, there is uncertainty as to whether this objective will come to fruition, as Sweden, despite being a partner of the UK on the Tempest and the FCAS program, has not signed on to GCAP yet. This suggests that the country is still considering its long-term plans for combat air and has yet to commit to the new GCAP team. Saab, the automotive manufacturer, released a statement in December stating its commitment to assisting the Swedish authorities in reviewing the Swedish FCAS context. Although Sweden is not a part of this international partnership, the company has been working alongside Swedish colleagues for years, ensuring that their goals and objectives align with requirements, timelines, and budgets, and the company remains engaged. Moreover, the government-to-government dialogue with Sweden continues, leaving the door open for them to join GCAP. BAE Systems is leading a core group of UK Tempest industry partners for GCAP, all of whom are determined to deliver a piloted supersonic demonstrator that is set to fly first in 2027. It will be intriguing to observe how the UK government defends its defense industry's lead design role in a program that could be dominated by Japan. This scenario could come to fruition due to a disparity in military spending between the UK and Japan, which is set to increase as Tokyo's defense budget grows significantly to counter China's threats. If Japan orders a significantly greater number of aircraft and invests more money over time, or at least has the leverage to do so, they may demand a considerable amount of work share and design lead authority in different aspects of the final product. Japan has recently decided to merge F-X with the UK and join GCAP. This decision was made after Lockheed Martin was ousted from Tokyo's sixth-generation fighter program and replaced by BAE Systems. The original collaboration between the US Prime and Mitsubishi Heavy Industries on F-X reportedly faced technical issues involving classified information restrictions. For the first time in a long time, Japan will not be aligned with the US on fighter jet cooperation. It is worth noting that Japan is used to being a junior partner with the US, even regarding their national fighter projects like the F-16. Despite not being involved in GCAP, the DoD has welcomed this move. The United States supports Japan's security and defense cooperation with like-minded allies and partners, including the United Kingdom and Italy, two close partners of our countries, in developing its next fighter aircraft. Discussions have started between the US and Japan on autonomous systems capabilities that could eventually complement the GCAP fighter. Concrete cooperation to work on the autonomous capabilities has already begun. However, the big question lingers. Will Japan's stealth stand out as the ultimate champion despite the GCAP? The answer was already complex, but now it's about to get even more intricate with Japan's entry into the fray. Thanks for watching. While you're still here, click on the link on your screen to watch another of our interesting videos. See you there.